Okay, today we're going to work with one-sided limits, and it's really not much different than what we've been doing, but what we're looking at is if I have some function f, and we were looking at what is happening with this function as it approaches a, and let's say that this value right here is L, okay? What we're looking at is what is happening as we consider a limit as we only come from the right. As we come down this function, what is happening with the function as we only approach it from the right, or what is happening as we only approach the function from the left. When we are approaching from the left, okay, then we think of that as approaching a from the left, and we put a little minus sign above it. When we approach a from the right, we put a little plus sign above it. So what we're looking at is left and right-hand limits, or one-sided limits. So here's a theorem for you. Theorem. It makes sense. The limit as x approaches a of f of x equals L if and only if and only if the limit as x approaches a from the right of the function is the same thing as the limit as when x approaches a from the left, and they both equal L. So if the left hand and right hand limits approach the same value, then we can say that the limit as we just approach the value exists. All right, so we must consider left and right hand limits. All right, so we're going to look at some examples here of how this plays out. First, how about the function the square root of x minus 2? We're going to look at several different situations. We're going to look at the limit of f of x as x approaches 2 from the right. We're going to look at it as the limit as x approaches 2 from the left. And then we're just going to look at it as the limit as just x approaches 2. Okay? We're going to look at all three scenarios. And this is an excellent case. We've been talking about looking at things numerically, analytically, graphically. This is a great case to look at it graphically. So this is our square root function, and where is it moved? It's moved to the right 2 units. So here's what we have. Somewhere on your paper, you should have just a quick little sketch of the square root function. Okay? Now, this is a good place for us to, I guess we could think of it as tracing the function, all right, or following the function. Let's look at a first. The limit of this function as x approaches, here's 2, as x approaches 2. So you can almost put your finger on it. I'll use my marker as my finger and say, what is this function approaching as we get close to 2? 0. That one's easy. Remember, we're looking at function values. As x gets close to 2, the function gets close to 0, the y values. Now let's look at b. let's take the limit as we approach 2 from the left. Well, there's nothing to trace, is there?
No.
This is a problem. It does not exist. Why does it not exist? Because there's no function there. If we looked at the domain of this function, wouldn't the domain of this function be 2 to positive infinity? Wouldn't that be the domain? Well, it doesn't exist over there. There's no function. All right, so there's no function values. So with that in mind, what is the answer to C? It does not exist because the left and right-hand limits are not the same. Now, just to kind of keep you straight on this, what if I would have added a part D and said the limit of this function as x approaches 4? Just so that we can kind of keep our skills sharp. What would that be?
0.
The limit as x approaches 4, well, isn't 4 over here?
Yeah.
Right? Isn't this just a substitution problem? The function is defined there, right?
Yeah.
So you would just put, you have the square root of x minus 2, you would just put a 4 in. The square root of 4 minus 2 is the square root of 2. Right? Remember that? That's what we spent a couple days doing. Okay? So let's make sure that we don't lose all those skills that we learned the last couple of days. All right. Let's look at another example. Let's look at the function, the absolute value of x over x. And we're going to look at this in the graphing calculator. So the absolute value button, by the way, is under the math menu. So you press math and you go over to number, and it's number 1. Absolute value of x, that's my numerator, divided by x. And why don't we, I'm going to save us some time here. Let's make our window, on our y's, let's make it -5 to 5. And then we'll graph it. That's interesting, isn't it? Well, doesn't that make sense, though? If I get this in to where I can write on it. If we think about this function and just look at it, let's think about it numerically. Aren't these two the same? What is x over x?
1.
Isn't it 1, right? So when the x's are positive, right, they're both the same. What's the absolute value of a positive? So if I have a positive 5 over a positive 5, I'm going to get 1. This does make sense, right? So now let's look at some limits. Okay, let's first look at the limit of this function f of x as x approaches 0 from the right. So as we approach 0 from the right, what does this function approach? 1. I think you can see where I'm going with this. What would the limit of this function be as we approach 0 from the left? -1, isn't it? Okay, this one's -1. As we approach from the left, it is approaching -1. It never changes from being -1. So, you know what's coming next. What would the limit be as x approaches 0? It does not exist because we are not approaching the same value from the left and the right. All right? We need to look at a piecewise function because they're so much fun. Let's look at this pretty little piecewise function, everybody's favorite, 3 minus x. That's for x less than 1. 4 for x equal to 1. And x squared plus 1 for x greater than 1. There's our piecewise function. There's nothing scary in that. We should be able to graph this one by hand. Let's do it just because it's so much fun. So when x is less than 1, it's 3 minus x. Well, isn't that a linear? Isn't that the same thing as negative x plus 3? Right? So we go up to 3. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 3, 4. So we're going to go up to 3. 1, 2, 3. Put my dot. And it has a slope of negative 1. So it's going to go down 1 over 1. Now, it says less than 1. So this is going to be an open circle, and I'm going to draw my line that way. So it is that function. Here's 3 minus x. It's 3 minus x when x is less than 1. Now it says that x is, the function is 4 right at when x equals 1. Well, here's 1. And up here is 4. Looks to me like we just got a dot there. Right? Now, the function is x squared plus 1. Let me get a different color. X squared plus 1 when x is greater than 1. Now, isn't that just a parabola that's moved up 1? Now, but we don't need to draw it to the left of 1. We only need to draw it to the right of 1. Well, we better consider what it is at 1. What would f of 1 be? Wouldn't that be 1 squared plus 1? 2. So it looks to me like it starts, my parabola starts here and then curves up like that. But notice that it does not include, we don't fill in that circle because this says greater than 1. All right? So that is the sketch of our piecewise function. Now, of course, we're going to look at what's going on around 1. Let's do some limits, just because they're so much fun. How about the limit as x approaches 1 from the right? I'm not going to write f of x. You know it's going to be there. What is the limit of this function as x approaches 1 from the right? As we approach from the right, isn't it 2? As we approach 1 from the right, doesn't it approach 2? Okay. What is the limit as x approaches 1 from the left? That is also going to be 2. What is the limit as x approaches 1? 2. So even though we have this, this screwy little dot up here, we don't care about that. We're concerned about what is happening as we get really close to 1, not right at 1. Okay? Right at 1, yes, we know it's way up here. But as we get really, 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 really close from the left and the right, from both sides, we're approaching 2. Okay? Now, in homework, you're going to have a handout that looks something like this. And let's look at it together. And I'm going to try to zoom in enough so you can see what this is saying. But that's probably a little too much. Okay. Number one. Number one says the limit, I believe it says the limit as x approaches infinity. Yes, the limit as x approaches infinity. So this is where we are looking at function values. All right? So what is happening to this function value as we approach infinity? What function value is it approaching? Now, if you look at this graph, see this right here? This label right here is supposed to be kind of like that. It's supposed to be h. So the answer to number one is h, right? The function, as we go towards infinity, infinity is way over here, the function is approaching h. Okay? How about number two? As we approach negative infinity, what is the function approaching? What y value is it approaching?
L.
What is that y value?
T.
It's an I. Okay? We okay so far? Please stop me if you're not. Let's look at number three. That is as we approach A from the right. That is an A plus. So as we approach A from the right, what is that going to? Positive infinity. How about as we approach A from the left? Here's A. As we approach A from the left, isn't that also positive infinity? Right? Now, how about when we just approach A? What do we say? We would say that it does approach positive infinity, but technically the limit does not exist. Would you agree? Because it's not, we don't know what that single value L is. All right? How about as we approach number 6, as we approach B from the right? Well, right here is B. So as we approach B from the right, what is the function going to? Negative infinity. How about as we approach B from the left? What is the function going to? Isn't that just 0? All right, it's right on the x-axis, isn't it?
Oh, I didn't.
Okay. So what would we say as we just approach B? It does not exist because they are not approaching the same value. Okay, and I think you see how this is going. How about the limit as x approaches C? Just regular x approaches C, not from the right or the left. Look at the function. It doesn't exist because they're approaching two different values. I want to skip ahead to number 11. Number 11 is not a limit, is it? Doesn't it just say g of a? So it's asking for the value of the function, right? Looks to me like there's an asymptote there, right? So right here at A, there's an asymptote, so this is undefined. Now this one's tricky, so pay attention. How about number 12? G of B. Now this is asking for the value of the function at B. Look carefully. Right here is B. It's M. The value of the function right at B is M. Okay, because it doesn't ask for a limit. It's not asking for a limit. It's asking what is the value of the function at b. All right, and at b, the value of the function is m. Okay? And so you're going to have a handout like that in homework tonight, and we're going to stop there for today.